discuss about inductor. We'll talk about inductor. As we see in the previous video, inductor and the capacitor are all storage elements. When you say inductor is a storage element, they can store energy. So how the inductor is made? When we say about inductor, is a coil which is turned in number of turn n is number of turn, and the element that make the coil itself, it has a permeability U, and we have the length L, which is the length, and we have the cross sectional area which make the coil. Now, to find the inductance, when we have all this, to find the inductance L is going to be equal L square UA divided by L. That's the formula that you use to find the inductance of inductor. We have the N is the number of turn, we have the permeability, and we have the cross area, and we have the length. Now let's see the physical of the element. Is it how the element is? The inductor is, we have the length, and we have the area, and we have the number of turn. The number of turn that we turn the coil, that is inductor. So this inductor is going to store energy as a capacitor. Now, since it is store energy, and mean that it have a voltage. It has a voltage when it cross the currents. Now both, let's see the relationship between the voltage and the current. The relationship between voltage and the current is going to be V equal L derivative of I by T. This is the voltage, the relation between the voltage and the current in inductor. We'll use this formula. The voltage equal the inductance multiplied by the derivative of I by T. Okay, let's see. It means that when I equal constant, when our current is a constant, voltage is going to be derivative of a constant equal 0. So the voltage is going to be 0. And we see in the previous video, when a voltage is 0, we call it short circuit. Why? Because I will have, let's say for example, I have my inductor that in the presentation will present like this one. And now when the current pass in this inductor, E is a constant, mean that our voltage is going to be a short circuit. Our inductor is going to be a short circuit. Why? Because the voltage from this formula, the voltage when the I is constant, the derivative of constant is 0, and the voltage will be 0. So it's going to be like this one. It's going to be like this one. Here is to be shorted. Here is going to be shorted. Why? Because the current through this one is constant I. So now we'll see that in a DC, why DC? Because the current will be constant, the inductor act as short circuit. When the current passing in the inductor is constant, it will act as a short circuit. Let's say an example. This one has physical different aspect of the inductor. It's going to be represented as this one. It's going to be represented as this one. It can as well as to be represented as this one. These are different type of inductor. In the physical, we'll see this kind of different inductor. You see, we have the number of turn, the other cross area. We have also the number of turn here that will be in this circle. This here we have the number of turn inside. Now, this inductor is mostly usually in a transformer. We already see about a transformer in the physical practical. So now these inductors are used mostly in a transformer. Let's see now another example how to determine the inductance of inductor. Now let's see, for example, this example. The current through a 0.18 Harry inductor. The unity of inductor is called Harry, noted by H. So he give me the inductor H equals 0.1, not H is going to be L is going to be 0.1 H, and he told me that the current passing in this inductor I is going to be 10t exponential minus 5t. IT equal 10t exponential minus 5t, 15 ampere. Now tell me, found the voltage across the inductor and the energy stored. Voltage, I know the voltage. What's the formula? The formula, as we know, V is going to be L derivative of the current by T, which equal the value of L gives me 0.11 multiplied by derivative of the current. What's the derivative of the current? I'm going to have derivative with respect of t of the current I. The I give me 10t exponential minus 5t. Now this 10 is a constant. I can bring outside. When I have 10 multiplied by 0.1 is going to be 1. So I will have 1 here, derivative 1 derivative with respect of t exponential minus 5t, which is going to be equal. As we know, when I have derivative of uv is going to be derivative of u multiplied by v plus derivative of v multiplied by u. Now derivative of t is going to be what? 1. So I will have exponential minus 5t here, because 1 multiplied by exponential minus 5t is going to be minus 5t exponential, plus derivative of exponential minus 5t is going to be minus 5 exponential minus 5t. So I will finally have minus 5 multiplied by the t exponential minus 5t. So if I want to factorize this one, I will have it to make a factor equal Vt, which is the voltage, equal exponential minus 5t 1 minus t. That is going to be my voltage. Why? Because this exponential is repeated minus 5t. Now I already found the voltage. I found the voltage, but it told me also to find the energy stored. Let's see, in this derivative, when I have derivative of u multiplied by t, it's going to be u prime v plus v prime u. I'll derivative the first function multiplied by the second function, plus the derivative of the second function multiplied by the first function. Is it how we did here? We have two functions, this t and this one. I take the derivative of this one multiplied by this one. Derivative of this one is 1 multiplied by exponential minus 5t plus, now derivative of this one multiplied by this one. Derivative of this one is going to be minus 5 exponential minus 5t multiplied by t. This one is constant 1 multiplied by any value equal to that value. Now let's see about the energy stored. As we discussed, that inductor is like capacitor, storage element. So it stores energy, and that we can use inductor to store energy. How to determine the energy stored? Now we know that V equal L derivative of I by T, and we know that the power is going to be V multiplied by I. That's the formula that we know. Now if I want to determine the power, is going to be this V, mean that V, this value, this one, L multiplied by I multiplied by derivative of I with respect of t. This one, L di dt, is my voltage multiplied by the I, this current. Now this is how we use the voltage. But what is the energy? Energy equal integration of the power with respect of t, as you know from the beginning of our lecture, our video. The first video we saw the relation between the energy and the power. Now I'm going to replace, it's going to be integration. What's the power? The power is this one. We'll have L multiplied by I multiplied by G di is T multiplied by dt. This dt is this dt. All this one is my P, my power. So this dt and this dt will go on. So finally I will have integration of L I di. Now if I have integration of I di equal what? Because this L is constant, so I have energy is going to be equal L integration I di. This one is going to be equal 1 by 2 I square. So finally is going to be my energy stored is going to be 1 by 2 L I square. That's the formula how to determine my energy. Now let's go back in our example to solve it, to finish our question. The example say that he give me this one, he give me I, he give me H. So the energy is going to be 1 by 2 multiplied by L 0.1 multiplied by E square, as in my E square, 10 T exponential minus 5 T whole square. So finally I will have 1 by 2 multiplied by 0.1 multiplied by 100 T square exponential minus exponential minus 10 t. That is my energy joule. Now let's go to another example where we will use under DC as we discussed that there. As we see, all will give us this electric circuit. It told us under DC, this one have to pay attention, because when you say under DC, what does it mean? It means that this one is a DC, and it means that when you under DC, we know that capacitor from the previous video act as open circuit. Now to know this thing, that open circuit, we will note it OC, and we know directly, we know also that inductor act as short circuit. We make short circuit. Now let's see, we have this one, we have this circuit. In this circuit we told us to find I, this VC, and IL, first equation. Now let's see, we know that this capacitor is going to be open circuit, this inductor is going to be short circuit. So what will be, how my circuit will be? My circuit will be like this one. Now this one is going to be as short circuit here, because it's inductor. So I have 1, 5, I have 4, I have 12 volt. I want to find this current I want to find IL, I want to find IL, I want to find VC. Okay, well, let's see. This current, no current will flow here because it is open. Since it is open circuit, no current will flow here. So mean that this current will just flow here, flow here, flow here. This current will flow here. So it means that since this resistor, and this resistor are flowing in the same currents, they are in series. So to find this current I and this current IL are same. So I is going to be IN is going to be in series. How to determine the currents in series? It's going to be the voltage, Ohm's law, 12 divided by equivalent resistor, 1 plus 5 is going to be 12 divided by 6 is going to be 2 ampere. Now we determine the currents. Now, how to determine this voltage VC? We have to know that this element resistor is this. Here it is the same wire. It means that this element in here, they are in parallel. This resistor and this VC is the same voltage across this this is the same the voltage across this resistor, because the parallelism. Now mean that VC is going to be voltage across this resistor is what? Ohm's law, 5I. It's going to be 5 multiplied by 2 is going to be 10 volt. Mean that I determine the value of VC. Now, what's the second question? The energy stored in the capacitor and inductor. We know that energy stored in the capacitor equal 1 by 2 C V square. As we see in the previous one, we have the value of C because the capacitor gives me 1 farad. I have the value of VC. The VC I already determined, and it's going to be 1 by 2 multiplied by 1 farad multiplied by 10 square. Now, how to determine the energy stored in the inductor? 1 by 2 L E square. Now 1 by 2. The L gives me 200 multiplied by 2. The I, the current thrown in this inductor, is 2 ampere because A equal IA 2 square. Determine. Now, if we have this kind of exercises, we have to know these two hints. When we know them, it will be easier for us to determine, to solve the question. Let's see another equation, another example. In this example also, we are going to determine under DC. Now we are going to determine under DC. So let's determine. We want to determine first. We know under DC. We know that inductor is shorted, capacitor is open. We know, no need to repeat again. So our circuit is going to be like this one. Or this resistor here is going to be shorted because it is inductor. We'll have these two. This one is going to be open since it is capacitor. Now I'll have 2 ampere here. I had 6 ampere here. And I have 10 ampere here. Now, what I need to determine the voltage across. I want to determine what? IL. Let's determine IL. We know that IL, now there is no current will flow here because it is open circuit. Mean that this current is the same current will flow through to this resistor. And these 2 resistors and 6 resistors are what? Are in parallel. So we know directly that I'm going to use current division. Current division. We know current division from the previous video. So it's going to be 6 multiplied by 10 divided by 6 plus 2 is going to be equal 16 divided by 8. 16 divided by 8, which is equal 7.5. So I will have IN equal 7.5. Now, since I already have IL, I can determine the energy stored in the capacity in the inductor. 1 by 2 multiplied by L. The L, I have it, multiplied by I square, IL square, the energy that is the current is thrown in this capacitor, this inductor. Now, I want to find VC. VC, the voltage across the capacitor. VC, I know. VC, if you see this voltage, this capacitor is in parallel with this 2 ohm. Mean that the voltage VC is the same as the voltage across this resistor. And to find the voltage across this resistor, I use Ohm's law, 2IL. Why IL? Because the current IL is the same current will flow in this 2 ohms. So I'll have 2 multiplied by IL, the value of IL, I have 7.5. I'll determine this. If I already determine this, I can directly determine the energy stored in the capacitor. 1 by 2 multiplied by C. The value of C gives me 4. C multiplied by VC square. VC square. The value of the VC, the voltage, I already determined from here. Now we'll see that we know first of we have to know that when we are in DC, when the current is constant, this one will be shorted. When this we are in DC, the capacitor will be open circuit because it will store energy. Now that is how we solve the